Let's examine problem 6.1a, payback period. When I think of payback period, I think of like gym memberships, or for me, I ski. I'm from Canada, so we have good skiing nearby. And here's my ski pass situation. It costs $1,000 to buy a ski pass to my local hill. It also costs $100 if you just want to buy a ticket for the day. So the math is pretty simple. I say to myself, if I'm going to ski more than 10 times, I'm getting my money's worth out of the pass. In other words, the payback period for the pass is 10 ski trips. We all have these types of things, and it's a very basic, I consider it a back of the napkin calculation you can do, and companies do it on their projects. They go, okay, well, this project costs us this much, but this is how much it's going to bring in. How soon does it pay itself off, right? How much do I need to use the project or whatever? How many years does it take to pay the thing off? So that's what we'll look at with problem 6.1a, a payback period. So Horizon Strategies is considering a project with the following cash flows. It costs us 60 grand up front, and you can see the payback over time. So the question is, how long until it pays back? And the way I do this is I just do a running total. So I go, okay, after year one, I'm minus 60,000. After year two, well, minus 60 plus 20, I'm minus 40,000, right? It was minus 60. I've made 20 grand, but I'm still in the hole on the project. After year three, I'm still in the hole by 10,000. After year four, I go positive. I go to 5,000. So I can stop there. Once I've gone positive with my little running total here, we can figure out the payback period. So it takes us 1 full year there. We still haven't paid back. 2 full years here, and then sometime in year 3 we pay back because we go positive. Now the math here is fairly straightforward. You just go, well, I was $10,000 behind, and I'm going to make $15,000 this year. So you take this number, divide by that number. So you go, okay, well, it's $10,000 is what I needed to make up, and that year I make $15,000, so it's 0.667. So how many years is it going to take me? 1 full year, 2 full years, and then 2/3 of year 3 to break even. So my payback period is 2.667 years. Okay. And again, you would be evaluating this against other projects, right? You have more projects typically than you have resources to do them. And so you'd say, well, this is, 2.67, if all the other projects are taking 4 and 5 years to pay back, you'd say, oh, this is a pretty safe project to tackle. But something that is lost here, because it's such a simple calculation, is the time value of money. The fact that these future cash flows, they are, money in the future is not the same as money today. So part B says, well, why don't we discount those cash flows? So I'm going to move and erase this stuff. And actually, I'm going to erase everything and just sort of start over. I trust you can rewind if you need those numbers. And we're going to do a discounted cash flow. So how do I discount them? Well, it's a 10% discount rate. The first number, well, you divide by 1.1 to the power of 0, which of course is just dividing by 1. This one divided by 1.1 to the 1, because it's a year from now. This one divided by 1.1 to the power of 2, divided by 1.1 to the 3rd power, divide by 1.1 to the 4th power, and divide by 1.1 to the 5th power. And we're going to figure out what our discounted cash flows are. So again, 60,000 divided by 1.1 to the 0th power is just 60,000 divided by 1. You can see I did it in my calculator there. And so it's 60,000. And of course, $60,000 in today, that's what it is in today's dollars. 20,000 divided by 1.1 to the 1st power. 20,000 divided by 1.1. 18,182. That's positive. So the first one, I put a little negative. It might be hard to see there, but I did squeeze a negative in. This is a positive number. Every other number here is a positive cash flow. 30,000 divided by 1.1 squared. So 1.1 squared. I go 1 over x times 30,000. 24,793. 24,793. 15,000 divided by 1.1 cubed. 1.1 to the power of 3, 1 over x times 15,000. 11,270. 8,000 divided by 1.1 to the fourth power, 1.1 to the power of 4. 8,000 divided by that, so 1 over x times 8,000. 5464. And 4,000 divided by 1.1 to the fifth power, for 1.1 y to the x 5. And then 1 over x times 4,000. 1 over x times 4,000. Okay, so finally I've got my numbers. 2, 4, 8, 4. Now, just as I did last time, I'm going to want to do a running total, but this time with the discounted cash flows to figure out, well, using only discounted cash flows, how many years or periods does it take me to kind of come out even or come out ahead? So negative 60,000 plus 18, 182. So 60,000 negative plus 18182. After 1 year here, I am still in the hole, minus 41,818. Let's add 24 grand to that, plus 24,793. After 2 years, I'm still in the hole, minus 17025. I'm digging myself out of this $60,000 hole I've made for myself. Plus 11,270, plus 11270. So after 3 years, I'm still in the hole, minus 5755. And after 4 years, you can see I'm still going to be in the hole, plus 5464. Minus 291. And so it's not until sometime in year 5 that I climb out of this hole. 291 negative plus 2484 positive is 2193. Okay, so I go positive in the 5th and final year. So it's going to be 4 point something years, right? Because I got 1 full year, 2 full years, 3 full years, 4 full years being negative before I finally go positive at some point in year 5. You take 291, divide by the discounted cash flow of that year to figure out which fraction of the year you're going positive in. So 291 divided by 2484 says 0.117. So let's call it 0.12. So 4.12 years. We're being overly precise for something that's going to happen 4 years from now. Will it be exactly 4.12 years? 0.1 of a year is whatever, a month or something like that. A little bit. It's about a month. 4 years and 1 month. It's maybe a little overly precise when we're making projections that far into the future, but that's how you do it. So we've solved the problem using the discounted cash flows. It's going to take us 4.12 years to pay back, right? And so that's useful information to have, right? The time value of money becomes highly relevant. And, the numbers were sort of manipulated to make that the case with our lower cash flows later. So that's why that's happened that way. But it's a useful calculation, a useful tool to have in one's toolkit. I hope this video was useful to you. I hope I was a useful tool. No, that doesn't sound right. I hope the video was useful to you. Have a great day. Thanks for watching. See you in the next video. Bye-bye.